So I'm going to review the concepts from the first 3 sections from Module 6 for your quiz. So in Section 1, we talked about graphs of quadratic relations, determining whether or not something was a quadratic, and then how A, B, and C affected the graph. So in our first picture, we want to know, is the graph a quadratic? And the answer is yes. And for the reason, we can put because it is a parabola. So remember, quadratic functions have that U shape that is a parabola, and it's evenly split in half at the vertex. Whereas if we look at our second graph, it is not a quadratic because it is not a parabola. So it can be simple as that when you're determining whether or not a graph is a graph of a quadratic. Okay. So now we're going to take a look at different values for A, B, and C. So we have the equation 2x squared minus 9x plus 3. And we're going to answer the questions based on the changes to that graph. And you can use Desmos to help you figure out the changes that have occurred. So we'll type 2x squared minus 9x plus 3. And then for our first equation, we want to know if we change it to negative 2x squared minus 9x plus 3, we want to know which value changed and explain how this will change the graph. So the A value is the one that's changed. And when A is negative, the graph opens down. And if you want to graph it in Desmos to see that, you're more than welcome to. Okay. So next, we're changing it to negative 2x squared minus 6x plus 3. So the value that's changed here is our B value. And what it's done is the graph has shifted around. We've not only moved up, we've also moved left, so quite a few things have occurred. Lastly, we have 2x squared minus 9x minus 1. So this case, C is the value that has changed. And whenever we change the C value, that moves the graph up or down, and so that's when the graph moves vertically. So vertically is an up and down direction. Vertex is at. Our vertex, opposite. So next we took a look at the 3 different forms of quadratic equations. So we have standard form, which is the y equals ax squared plus bx plus c. We have vertex form, which is y equals a parentheses x minus h squared plus k. And then lastly, we have intercept form, y equals a x minus p x minus q. And each form tells us something different about the graph of a quadratic. So we first have the equation y equals negative x minus 1 squared plus 1. So first we want to identify what form our quadratic is in. And it is in vertex form. So the nice thing about being in vertex form, we can identify the vertex from the equation. So when we identify the vertex from vertex form, we do the opposite of what's with x in the parentheses. So if it's x minus 1, that's going to be a positive 1. And we keep the y value, which is positive 1. Now there are 2 different ways we could then find the y-intercept and the x-intercept. The first is to expand that x minus 1 squared and then distribute and get it in standard form. We can also graph it in Desmos and pick out the information there. So the y-intercept is where our graph crosses the y-axis, and if you look at the graph, this happens at the point 0, 0. Okay. Next, we want to know the x-intercepts. So one of them is pretty obvious. We have an x-intercept at 2, 0. But we also have a second x-intercept, and that is also at 0, 0. So 0, 0 is not only a y-intercept, but it is also an x-intercept because it's the origin. Our next example is y equals 4, x minus 2, x plus 1. So this time we are in intercept form. Okay. So when we get down to the x-intercepts, we're good to go. So to figure out the vertex, we graph it in Desmos. The vertex is either that minimum or maximum point, depending on which direction your graph opens. So in this case, it's the minimum, which is at 0.5, comma, negative 9. We can also identify the y-intercept, 0, comma, negative 8. Now, because we are in intercept form, the x-intercepts are given to us from the equation. So we do the opposite of what's in each set of parentheses. So x minus 2 would mean there's an x-intercept at 2, 0. And then x plus 1 would mean there's an x-intercept at negative 1, 0. And you can also use Desmos to double check, and you will find that those are the x-intercepts. We also have to be able to write the equation of a graph in vertex form or intercept form. We don't typically use the graph of an equation to put it in standard form because standard form really is only helpful for opening direction and y-intercept. So we're going to assume that A is 1 here. So for vertex form, I need to know where. So go ahead and label, which is at negative 3, negative 1. So we write our equation, we'll do y equals, A is 1, so we don't have to put anything in front. We do the opposite of x in the parentheses. So x minus 3 will be x plus 3 squared. And then the y value we keep the same, negative 1. Now we're going to do the same thing, but we're going to put it in intercept / factored form. So we identify our x-intercepts, which are at negative 4, 0 and negative 2, 0. So we're going to do y equals, A is 1, so we don't have to worry about putting anything in front. Then we do the opposite for both sets of parentheses. So a minus 4 would be plus 4, and a minus 2 would be plus 2. And you can also graph both of these equations in Desmos to make sure they match the picture we're given. The one thing I forgot to talk about is because this parabola opens up, we also left a positive. We didn't have to put a negative in front of either set of parentheses. But if this opened down instead, I would need to make sure I put a negative in front to account for that. Do the x. And then in section 3, we talked about converting between forms of quadratics. All right, so this is where we're going to do the math to go between standard form to vertex and intercept and vice versa. So we want to take our quadratic that is currently in intercept form and put it in standard form. So what we do is we distribute. Okay, everything in the first set of parentheses multiplies to everything in the second. So x times 2x is 2x squared. X times 1 is x. Negative 7 times 2x is negative 14x. And negative 7 times 1 is negative 7. We combine like terms and we get 2x squared minus 13x minus 7. And you can always double check your work with Desmos. Your graphs should line up directly on top of each other, and you know that you've done it correctly. Okay. Next, we're going to go from vertex form to standard form. So first we have to expand our parentheses, then we distribute. Okay. So we're going to have y equals x minus 2 times x minus 2, and then our minus 10. When we distribute, x times x is x squared, minus 2x plus 4, and we still have our minus 10. Combining like terms, we get x squared minus 4x minus 6. So now we're converting to vertex form. Okay. So there's a couple different ways you can do this. The first way I'm going to do is using Desmos. Okay. So I can graph my equation in Desmos, y equals 2x squared minus 5x minus 7. Identify the vertex, and then do what we were doing before. So 1.25 negative 10.125. The important thing you need to remember here is the a value. The a value in standard form is still the a value in vertex form. So because the number in front of x squared is 2, we're going to have a 2 out in front. Then do the opposite in the parentheses, so x minus 1.25 squared. Then we keep y, negative 10.125. Our other option is to do it algebraically using completing the square, which is really only useful if you have a quadratic whose leading coefficient is 1. Otherwise, it gets a little bit more difficult. Okay. So first, I'm going to break up the x terms from the constant, and I'm going to put it in parentheses. So we have x squared plus 6x in our parentheses, and then our 5 outside of it. I need to figure out the value that will make what's in parentheses a perfect square. So we do b divided by 2, and then we square it. So 6 divided by 2 is 3. 3 squared is 9. So if I add 9 in my parentheses, I have to subtract it outside the parentheses. Because if I were to get rid of those parentheses, I'd have to be able to combine them and get what I originally started with. Okay. Now we're going to factor the quadratic in parentheses. And it's always going to factor as a perfect square. The same thing in both sets of parentheses. So the number that multiplies to 9 and adds to 6 is 3 and 3. So we'll have x plus 3 in the parentheses. And then we do 5 minus 9, and we get negative 4. You can also go the Desmos route, figure out the vertex, and put it in vertex form. Lastly, we are converting to intercept form. So the way we're going to convert to intercept form is by factoring. Okay. So in y equals x squared minus 10x plus 16, we're looking for the numbers that multiply to 16 and add to negative 10. So if I go through the numbers that multiply to 16, we have 1 and 16, 2 and 8, and 4 and 4. And the only way I'm going to get two numbers that add to negative 10 is if I use negative 8 and negative 2. So we're going to have y equals minus 8, x minus 2. Our last example, y equals x squared plus 9x plus 20. We're looking for the numbers that multiply to 20 and add to 9. So 1 and 20, 2 and 10, and 4 and 5. And the numbers that add to 9 are 4 and 5. So we have y equals x plus 5, x plus 4. And for every problem I did on this page, you can also, once you have it in the other form, whether that's standard form, vertex form, or intercept form, graph your original equation and your new equation in Desmos and make sure that they match. or graph the first equation in Desmos and make sure that when you put it in vertex form or intercept form, you get out the same information, like that your vertex matches and that your x-intercepts match. Okay. If you have any questions over anything from these 3 sections, please let me know before your quiz.